So for those of you that don't know, my name is Ian McLaughlin. I'm actually a computer science major at RPI. I am a member of RCOS, but you probably don't see me around here a lot. I'm in the Class to Go team. And unfortunately, my work keeps me very busy. But I started a little cloud computing firm over winter break. I'm going to give you a demo of exactly what it does right now. One second. So you guys know speedtest.com. It's a popular website for doing latency testing to servers they have around the world. And I'm just going to run two tests real quick. One using Liquid Sky, and both Google Chrome, and one just using the internet connection. Well, its resolution is pretty difficult. So the right one obviously is using Liquid Sky. The left one is just your actual internet connection here. I actually want to do this demo on a PC, so give me 1 second to. So how many people in this room have ever had a program or a game or a rendering they haven't completed on time, or something that requires more power than they've had to do? Just a show of hands. Maybe it's a game, program, internet speed, download. Liquid Sky, your computer is in the cloud essentially hosted. And it dynamically changes to meet the program that you're using. Alright, what is this? So it has two clouds, your desktop cloud and your app cloud. With the app cloud, application data and video is actually streamed real time using the NVIDIA CUDA to the client. It resizes just like a normal window. As you can see, I wrote it for a PC, so the arrow's kicking in. It doesn't exactly look right on a Mac, but it resizes, there's no latency, and as you can see, everything's a lot faster. It's actually enhanced with NVIDIA virtual GPU technology, so it supports up to 6 gigs of graphics memory. One of the apps I'm working on right now, I don't know if it's installed right now, is Steam. And once you have that, a client will be able to come in using a netbook, Linux computer, anything. Actually open up Steam. It'll open as a normal window without installing any software. It has access to USB ports on your computer if you give it access. It's powered by Citrix receiver HDX technology, so it's high definition, scalable over wide area networks. It supports resolutions as high as 1080p. And let's see another demo, just to show latency. I got paint on here, just to be cool, because yeah. It also has license pooling, so I can actually save money by pooling licenses together using enterprise licensing software and actually license out software. I'm hoping after today to take on some beta testers, and they're going to get to use some software for free, but in the long run there'll be packages that people will get to use. But I'm doing a pretty horrible job explaining what it is, so let me go through that right now. Liquid Sky, I always wanted to be able to help people starting out companies or have ideas. People doing Autodesk programming or renderings, and didn't have the power requirements or consumptions that they could afford. And it seems kind of redundant and stupid to have all the hardware on the client side when these days internet speeds are fast enough to transfer 60 frames a second of high definition video with no latency to clients. So as you probably heard, the new Xbox uses technology to stream and compile video server side back to the Xbox console when it actually has a fast enough internet connection. Enterprises have been using VDI solutions for the past 20 years to help reduce costs. Actually, RPI uses it here. It actually uses Active Directory and streams data to every single node on the network. So this software turns any computer into that node and actually uses protocols which I've written to stream it across a wide area network to a client at the same latency that you would experience in a company. My servers support this thing which I'm calling liquid dynamics, which is where a user pays for a basic package of hardware for his cloud computer. And opposed to desktop, Amazon Elastic Cloud Services, or any other cloud company that expands elastically, allocating more resources as users pay for it, Liquid Sky expands as liquid. And what that means is a user pays for his minimum hardware, and then free of charge, if he logs on at like 3 in the morning, he gets the rest of the hardware free of cost. Using hot socketing and dynamic RAM, dynamic CPUs, some cold socketing, I can actually change the hardware of a client's computer free of charge instantaneously. So while you're logged in, 1 second you may have 2 gigs of RAM because that's what you pay for. And if a bunch of people log off my cluster, all of a sudden you have 60 gigs of RAM. You can have up to 10,000 megabytes of video RAM, and you can have up to 60 cores of processing power free of charge. The reason most companies, hosting companies, are actually doing dedicated hosting solutions is because they don't know what to do with the hardware when they're not using it. While this is considered a dedicated hosting solution, and you'll always have enough resources allocated to you to complete a task, whenever you're not using the hardware, I'm using it as a sales pitch to actually lease out the hardware to other clients. So anyone, free of charge, as I said, at like 3 in the morning can have the power of a supercomputer, as long as no one else is logged on. So the beta testing I'm doing this week, I'm hoping to pick some people up here. I'm starting out with my networking protocols, so I've created some switches written in OpenBSD. pfSense is the name of the Linux kernel I'm using. And it's basically a router. It's going to throttle different clients around and try and support liquid dynamics for networking. Then next week I'm going to implement the rest of my algorithms, starting with dynamic RAM. I already tested it using 10 users, but I want to try using like 30 or 40. I have one angel investor right now, and he's supporting the cluster of servers I have going right now, which should support about 100 clients. So hopefully I can keep coming to these meetings and get more people. The actual Liquid desktop side, so there's 2 clouds, apps and desktops, actually renders an entire desktop instantaneously. It's in a suspended state, and then it comes online the second you connect. There's virtually 0 latency, as you can see. This particular model has 3 gigabytes of NVIDIA graphics memory, and it uses virtual GPU technology, so it actually supports some pretty serious gaming. It'll run full screen on any computer, that supports 1080p. So this looks horrible right now. Not a very good demo, but it looks really nice over here. Anyways, the cool thing about my servers is they all actually have Active Directory Windows clients constantly running. And what happens is you have this thing called a virtual disk, which is actually a technology I'm licensing from Citrix. And that personal disk follows you around and actually monitors your changes in your computer and stores them inside of this hard drive. So even though you're logging onto a computer, which you actually have administrative privileges to, it's a different computer every single time, and it's storing all the changes inside of the V disk. You also have complete access to your local drive. And naturally it's going to pop up and make sure you're okay with that. You have access to USB components, hardware, CD-ROM drives, audio, webcams, the whole deal. Ironically enough, when I ran my testing, if you use Liquid Sky and you download a software and you save it locally on your computer, it actually running through this network tends to be about 6 times faster than if you were actually downloading from the site. And the reason for that is servers tend to be very close together, wired either fiber optically or just public IPs in general. They're all routed through the same place. So whenever you download something using Liquid Sky, you're actually given an IP address that's assigned. It's not a public IP address, but it's very close to the other servers because it's actually going through every single client on my server actually has its own public IP that goes through a router and then distributes another lease using DHCP. So I'm not very good at explaining anything. But if you look down here, oh wait, this is actually the Mac version. Whoops. So let me just open up Google Chrome. If you actually go to speed test, it has a little IP lookup, so that's kind of nice. If you actually put the IP address I'm getting right now, it's actually data room in New York City. That's where the cluster of servers I have is right now. So that IP address is going through a firewall, which is forwarding the proper reports from my HDX protocols that go straight to this computer, so it's a direct peer-to-peer connection. which is a lot faster than any of my competitors right now. And as I said, to date, there actually isn't a single company doing desktop hosting services. They're all doing dedicated solutions. So they're all hosting, Windows Server, or they're hosting, Ubuntu Server, hoping to generate clients that are going to do web hosting, dedicated solutions. You can actually do web hosting, and in fact, you can configure to forward the port 80 through the public IP that your computer has with this service. But naturally, I'm trying to generate intermediate users. And the reason for doing this is the cost comes down to about 1/3 of what you pay for the actual computer itself. So the only people who wouldn't actually benefit from this technology are people living in the woods or some kind of serious lack of internet, because I actually throttle my laptop down to about 1 megabyte a second of internet connection speed. And no matter what the connection speed is, well, obviously it has to be above 1, but it actually just compresses the video, so kind of like a YouTube video, but it will never actually generate any latency, or it should. So with that, yeah, it's about 1/3 of the cost overall. My servers will have a giant pool of Windows machines running and Linux machines. It supports those two operating systems. It actually supports Mac OS right now. I wrote that all in, but they're not going to give me any licensing, so I'm just going to leave them alone. But yeah, so the machines are running. People log into them. They're automatically given administrative privileges. And if they try and corrupt anything with the computer, it doesn't really matter, because the second they log off, using virtualization, I use a snapshot, and I actually revert back to the original settings. So, how many people here use an emulator, or N64 or anything? So emulators suck, because they're very slow. They actually go down to a circuitry level and emulate components in the hardware. With computer emulation, however, you're actually able to do something called direct hardware I/O. So you can actually access components in the hardware, such as the CPU and the GPU and the memory, in an isolated environment directly.
So things like VirtualBox do that?
Yeah, exactly. VirtualBox does that. Unfortunately for VirtualBox, it actually has to go through the operating system kernel, so that can be kind of slow. But for all intents and purposes, the virtualization of these computers that I'm doing, their kernels are actually configured to allow direct, complete access.
Like Zen or something?
Sorry?
Zen?
Yep, it's all written in Zen open source. That's why I'm going to release this open source, so I figured I'd start with a platform that was open source. The hypervisor I'm using is Zen. It's a Citrix product, completely open source. And I actually wrote implementations for VMware because they got slightly better results in my benchmarking. But VMware, the licensing is pretty expensive, so I'm just trying to avoid them right now. And I like how Citrix actually has a partnership with NVIDIA, which is the biggest graphics company in the world right now. And they are doing some pretty serious virtualization graphics emulating right now. So my servers have Grid. You ever heard of NVIDIA Grid GPUs? Kepler GPUs were designed to emulate and virtualize and hyperthread and all that, and pass to different machines. So essentially, this is all being virtualized on a server, which allows for snapshotting, imaging, cloning, direct hardware access. So it's just as fast. Each of my clusters receives a 10 gigabyte a second internet speed, and that's divided up among users. And like I said, you pay for a package, and that guarantees you a certain amount of minimum allocated hardware, and then from there,
Load balancing is done on that.
yep, from there you automatically get the rest of whatever's available. So if someone logs off, you get the rest. And it's all about 1/3 of the cost you pay for the computer in real life. So, and I'm actually hoping to implement some of Citrix's solutions for enterprises that allow offline use using expiring licenses. So you can actually take that virtual image, store it on your computer, and run it if your computer supports virtualization VTD technology, which every computer does these days, running an Intel CPU. That's obviously not the fastest way, but the cool thing with these apps is they'll actually run locally. And then the second you, because it actually downloads the entire virtual image of the application, and the second you have access to the internet, it'll stream the video from my server, the mouse movements, the keyboard movements, the USB data, and it'll actually leave the entire thing in the cloud. Same way it would work on an Xbox, using NVIDIA SDK for streaming Windows and Zen SDK. Anyone have any questions? I ran through really fast. My first time presenting it. Yeah.
What happens if the user is rendering a video at 3 in the morning using 16 gigs when they only have 4, and it takes like 6 hours, and a bunch of users log in while the video is still being rendered?
Yep. Yeah, so that's the whole thing, is over allocation. It's something I don't want to happen. So that's why Liquid Dynamics, which is the trademark that's, I guess I patented, I don't what do you call it right now, but that's what's running right now. It actually is able to pull away RAM virtually because the operating system does all the RAM pooling. It actually creates pages and everything, and see the CPU usage. I'm testing 3 algorithms. That's the point of the beta testing. The first algorithm is actually direct dynamic RAM and hot socketing. So it's going to literally take away from a user while he's using it. So if you have an application running that's rendering a video, it's going really fast. All of a sudden, it's going to slow down. Your RAM is going to literally, the operating system, ever since Windows 7, actually is okay with RAM changing while the computer's running, as long as it's in a virtual environment.
And it would just start paging the disk. It would
Yeah,
just slow, but still work perfectly.
The operating system will start paging, or the second algorithm I'm going to test is actually my hypervisor starts paging, and you see the same amount of RAM in your computer, because I want to see if hardware has any problems with that kind of thing. CPU is a little bit more complicated. My testing hasn't gone so well just yet, but I can still change the amount of CPU sockets or cores that you have while your computer's running. But it's looking a little bit messy because some applications actually check how many cores you have and optimize themselves accordingly. So it's looking like the algorithm I'm going to use for that is the one I wrote, which just literally says, you always look like you have 8 cores. And then my hypervisor will actually give you more and reduce them and thread them and hyper-thread them on its own. But yeah, according to your software, it'll just go slower. The operating system actually pools and pages all the memory in the RAM. Your software can detect how much RAM there is, but it's very rare to see any software actually care how much RAM you have because it's done at the operating system and the kernel level. So yeah. So.
From a business standpoint, so basically when a consumer buys a package from you, whether it be 2 gigs of RAM or 32 gigs of RAM, what they're buying is a minimum. So they'll always have that much. Sometimes when they log on, there's free
Sometimes
space.
they got a lot of crap.
Got a lot
Yeah,
more.
exactly. It's literally to help the little guy who can't afford the crazy computer, you know? He logs on at 3 in the morning, a dedicated person who wants to try and render something, start a business, compile some crazy code. I don't know who's tried to compile like Google Chrome, it takes forever. It's insane. And that's, mostly a CPU compile time anyways, and the GPU algorithms aren't exactly there yet. I haven't exactly written them yet, so I'm trying to avoid that altogether. They're dedicated GPU packages right now, and everything else changes dynamically, the RAM and CPUs. But yeah, at 3 in the morning, someone can just have a ridiculous amount of stuff for free. And that's pretty much my sales pitch to get people to use the software. That, and it's about a third of the price.
So how well does that scale up?
So scalability, with a business, the whole model of Amazon, Elastic clusters and everything is, okay, we got more clients, we add more servers. Those guys, as the company grows, they can expand their servers as they want. You're given the ability to actually change your package once every day. It's a recursive payment, so it's a monthly fee. As I see that there are more users, I purchase more servers. I'm actually outsourcing to New York City and Europe right now. I have 2 clusters right now. As I see that there are more users, I have to allocate more machines, and there's actually a master image of each type of machines that just gets cloned. And then it automatically joins Active Directory. And it's already configured because it's based off the master image. All that changes is the MAC address, and that triggers the operating system to say, this isn't the same computer, and then freaks out, and then everything works. So yeah. Sure, yeah.
So I do see it like it'd be great like running something like crazy, say like compile a Google Chrome, but like my question is, if I'm trying to run some local program, which like might not be able to run on a local computer, such as like Crisis 2, are they able to do that? Because I want to see like, do you have to upload the entire software to the server side or what?
Yeah, so for applications, the applications I actually have to go in and configure because, believe it or not, some applications aren't okay with being completely stripped down, turned into one window, and then streamed. So I have to go through and configure the applications accordingly. During the beta, I'm going to be offering free software to you guys because I can't get licensing and I don't want to get sued just yet. But I'm going to actually start supporting paid software with pooled licenses that the developers are okay with. So you'll be able to use Autodesk, AutoCAD. One of the things I'm most proud about right now, which I'm hopefully going to release next week, is Steam. It literally would just be an app, you click on it, it actually supports all the windows that come underneath it, and you have administrator privileges to install the games, and the local directory the application runs in. So you can install games, stream them, and you have your entire own store, basically, right there. It supports USB pass-through. I'm using Citrix's algorithms for receiving and USB pass-through and everything, so there's basically no latency. You can use a gamepad, mouse, keyboard, the whole deal. But yeah, locally, you don't have to install anything. You install one plugin, which comes over via JavaScript, by Citrix, which is their streaming algorithm. They own LogMe and Hamachi, which is one of the biggest companies, and I can't really compete with them, so I'm just licensing out to them. And that's what handles the actual compression and streaming of my software. So, but you don't install anything locally except on the actual, if you own a Liquid desktop package, the apps are separate from the desktops. I kind of launched them at the same time, even though I was told not to. But the apps, they're a lot cheaper. Users can go and just pay for one application, don't need to get a computer. The desktops are actually entire environments. Yes, you'd have to install your software on them. But you actually also have access to the applications that you've got on the app side inside of your Liquid desktop, because it's all the same Active Directory service. Sorry. Did I answer your question? I kind of.
Yes.
All right. I haven't slept in 2 days.
Wait, so
It's gone.
is it limited to just the apps that are chosen, or can the user install arbitrary software?
I'm hoping someday the user will be able to install arbitrary software, but for now, these actual applications, I install them as an administrator on an instance of Windows Server with administrative privileges. So that would be a crazy hacker's dream if I gave anyone rights to do that. I have 3 instances of domain directory servers and then 1 actual application server, because Windows Server supports multiple users. That actually has administrative rights, so I don't want to give that up ever. I'm probably going to go in, I'm going to go to guys, I'm going to go to different software companies, ask them if I can embed their software in my product and give them a royalty, and then I'm going to sell it. That's the plan, anyways. On the desktop side.
All right, so before this keeps going, it's 5:10. We actually need this room for something else, so we should probably cut this off here. Thank you very much. If you still have questions, pin them down outside in the hall.
Yeah, I'll be around. Sorry.
Okay, so then what was the thing?
So that means go up to him and talk.